right, day 5 knows independence. When working with probabilities, we often perform more than one event in a sequence. This is called a compound probability. Compound probabilities are more complex than a single event probability to compute because the first event might affect the probability of the second event. Not always, but sometimes. For example, the probability of getting a head on a single flip of a coin is 1/2. If you flip the coin and get a head, the second flip's probability is still 1/2 because the first flip doesn't affect the second flip. The second flip has the exact same probability as the first one, 1/2. When the first action does not affect the second one in any way, the events are known as independent. Think about it. If you say, I'm independent, I do my own thing, what you do doesn't affect me, same thing. If the first event does not affect the second one, it's independent. So, 2 events, A and B, are independent. If the fact that A occurs does not affect the probability of B occurring, or vice versa. So, here are some examples. Getting a head after tossing a coin and selecting a purple marble from a bag. Okay? Flipping a coin does nothing to the marbles inside the bag. Getting a head and rolling a 2 on a 20-sided die. Again, the coin does not affect the die. Choosing a jack, replacing it, and then choosing a king. This is important. If you take a deck of cards, there are 52 cards. If you take a jack out and leave it out, now there's only 51 cards. But if you replace it and then choose a second card, it's like you're starting all over. It makes no difference. Independent. So to find the probability of 2 independent events that occur in sequence, find the probability of each event and then multiply them. The multiplication rule is defined symbolically below. Note that the multiplication is represented by and. That's and. That's supposed to be a D right there. Kind of like up here, and. That's why we have it in bold. So, what is the probability of rolling a 6 and then rolling a 5? Okay? Well, the probability of rolling a 6 is 1 out of 6. On a normal 6-sided die we're talking about here. The probability of rolling a 5 is also 1/6. So the probability of S and F both occurring is the probability of S times the probability of F. So 1/6 times 1/6, which is 1/36. Remember, hit pause if you need to. Given a bag of marbles with 3 red, 2 green, and 5 yellow. That's 10 marbles total. Always want to know the total. What's the probability of choosing a red? Replacing it, very important here. So there's 10 again, and then choosing a green. So, probability of choosing a red. Well, there are 3 red out of 10 marbles. The probability of choosing a green. Well, there's 2 green marbles out of 10. So the probability of choosing a red and a green is the probability of red times the probability of green. So 3/10 times 2/10, which is 6 out of 100. And remember, we don't have to reduce it. Okay, probability of getting a head on a coin. So probability of getting a head is 1 out of 2. Then then choosing a purple marble from a bag that has 2 purple, 1 green, and 2 orange. That's 5 marbles. Therefore, our denominator is going to be 5. The probability of getting a purple is 2 out of 5, 2/5. So the probability of the heads and purple is the probability of heads times the probability of purple. So 1/2 times 2/5 equals 2/10. True false question. Okay? 2 possibilities. Shouldn't put that there because that's the next question. So true false has 2, followed by a multiple choice question with 4 possible answers. 1 correct and 3 wrong. What's the probability of getting both questions correct? Okay. So the probability of a correct true and false, let's do correct, true, false, whatever, is 1 out of 2. The probability of a correct on multiple choice is 1 out of 4. So, probability of both, just got shorthanded here now, so we've kind of been writing it every time, is 1/2 times 1/4, which is 1/8. You have a 1 in 8 chance of getting them both correct. Now, understanding independence is critical to probability. We must always take it into account how one event affects the next event. Determine if these are independent or not. So the date, sorry, this didn't print right. That's the amount of sunlight. And this is your favorite color. I don't think it printed that way on your page, but it did for some reason on mine. So the date and the amount of sunlight. That is not independent. Because different times of year have different amounts of sunlight. Hence daylight savings time. So therefore, time of year does affect it, so it's not independent of each other. Income and education level. Not independent. There is definitely a correlation between income and education level. Your height and your favorite color. That is independent. One does not affect the other. Determine the probability of A and B if they are independent. So if they're independent, we're going to take 0.1 times 0.3, which is 0.03. 0.25 times 0.8, which is 0.2. 0.5 times 0.5, which is 0.25. So the probability of A and B is 0.25. All right, mutually exclusive and independence. A common misunderstanding is that independence is the same thing as being mutually exclusive. Independence is about whether one event affects another's probability or not. Mutually exclusive sets are those that don't share any elements. Independent sets are those that don't impact each other's probabilities. So mutually exclusive is about sharing of elements. What they have in common or not. And independence is about affecting each other. earlier, replacement and non-replacement. The term replacement and no replacement gets used a lot in compound probability problems because they describe what you did with the first thing that you selected. Did you put it back or did you keep it? So, getting a green marble, replacing it, and getting another green marble. That is an independent event. I'm going to abbreviate. Picking a black queen, not replacing it, and getting an ace, that is not independent. Because you had 52 cards, and then you only had 51 cards. Those two words are huge clues as to whether the events are going to be independent or not. Okay, replacing and not replacing. So if you replace, independent. Not replace, not independent. Look at the word, not and not. No replace, not independent. Replacement. Because the item is replaced, it resets the event back to the original, and nothing has changed. Thus, replacement tells us that the events are independent. But with no replacement, because it's not being replaced, the probabilities are altered. Thus, no replacement tells us that the events are not independent. Very important. So, determine if these are independent or not. Picking a marble from a bag, replacing it right there, independent. Picking a marble from a bag and then spinning a spinner, again, independent. Now, we don't see the word replace, but that's because we went from bag of marbles to a spinner. Since one does not affect the other, it's independent. Picking a card from a deck, not replacing, so not independent. Key word, not. All right, last concept. Testing for independence. We can use the formal relationship of probability of A and B, meaning probability of A times the probability of B, to test it. Here are 3 examples of how we could use the probabilities to determine if they're independent of each other. So, probability of A is 0.8, B is 0.4. 0.8 times 0.4 is 0.32, which is not 0.2, which means that these are not independent because the math doesn't work out. 0.6 times 0.5 is 0.30, which is the same as 0.3. Therefore, these two events are independent. The math works out. Probability of A times probability of B is 0.3. At the same time, a test can occur, but the information will be given in a Venn diagram. So, check to see if probability of A times probability of B equals the probability of A and B. Now it says here the probability of A is 0.5. And you may look at this and go, no it's not. But yes it is, because this is all A. 0.25 plus 0.25, that's 0.5. And then 0.5 for B, this is all B. So A and B are 0.5. What we're going to look at is the intersection here. So 0.5 probability of A times 0.5 probability of B is 0.25. Does that match? Yes. So therefore, these are independent. Again, you have to add these two together. 56 cents plus 14 cents is 70 cents. That's your 0.7. So 0.7 times 14 cents plus 6 cents is 20 cents, which is 0.2. 0.2 is 0.14. Matches. Independent. Remember, the key thing is, if you did not have this information here and you just had the Venn diagram, you have to remember to add those two for A, add those two for B, and then multiply. Last but not least, add these two together, you get 0.5. Add these two together, you get 0.28. 0.5 times 0.28. Sorry, that's 0.28. I don't know why I wrote 5. So 0.5 times 0.28 is 0.14, which does not match A and B, so this is not independent. That's it.